Good day, viewers all over the world. You are welcome to Toydale online class. Today, we want to talk about the angle between two lines. Angle between two lines. So, as we have it on the board, there are two lines here, line AB and CD. And we have talked about the slope, angle of slope. So, in this case now, if we let the gradient, which is the slope of AB, to be equal to M1, and the gradient of the line CD, the second line, to be equal to M2. Then under the angle of slope, tan of that angle, like tan alpha 1, will be equal to the gradient. Then tan alpha 2 will be equal to the gradient of the second gradient, M2. But we know from our knowledge of trig, from our knowledge of angles, that alpha 2, the exterior angle here, is equal to the sum of interior opposite angle. That is, alpha 2 can be equal to alpha 1 plus alpha. Then if I make alpha the subject formula, I'm going to get alpha 2 to be equal to alpha 2 minus alpha 1. Then tan alpha, the angle, the tangent, this is the slope between the two lines. Tan alpha will be tan alpha 2 minus alpha 1. So from our knowledge of trig, we know that when we have tan A minus B, the expression with tan A minus tan B, over 1 plus tan A tan B. So in this case now, this is what we are going to resolve to. Then tan alpha 2 is given as M2, tan alpha 1 is given as M1 in that order. If I substitute, that is what we are going to get. At the end of the day, tan alpha will be M2 minus M1 all over 1 plus M2 minus M1. But from there are two conditions. If the two lines AB, if line AB is parallel to line CD, then the angle between them will be 0. So tan alpha will be 0. From here, tan alpha will be 0. If tan alpha is equal to 0, we have 0 to be equal to M2 minus M1 all over 1 plus M1, M2, M1. Then if I cross multiply, M2 minus M1 it will be equal to 0. So M2 will be equal to M1. Invariably, if two lines are parallel, their gradient is equal. That's the first condition. The second condition is when the line AB is perpendicular to CD. If the two lines are perpendicular, that simply means that alpha will be equal to 90 degrees. Then tan 90 degrees will be equal to M2 minus M1 all over 1 plus M2 M1. So from this place now, tan 90 degrees is undefined. Then we are going to give tan 90 degrees is undefined. That's undefined. When we have tan alpha, in this case now, tan alpha will be undefined. That's tan alpha. Tan alpha will be undefined. So, this is tan alpha. It will be undefined. And the implication of this is that when alpha equal to 90 degrees, tan alpha will be undefined. Then the implication of this is that this fraction, M2 minus M1 all over this, will be undefined if the denominator equal to 0. That is, for us to be able to get this fraction to be undefined, the denominator must be equal to 0. That is, we have M2, M1, 1 plus M2, M1 will be equal to 0. Then M2, M1 is equal to minus 1. So this is the condition for perpendicularity, and this is the condition for parallelism. So if two lines are parallel, their gradients are equal. But if two lines are perpendicular, the product of their gradients will be equal to minus 1. The product of their gradients will be equal to minus 1. So we should note that if two lines are parallel, the gradients are equal. If two lines are perpendicular, the product of their gradients will be equal to minus 1. So we take example. Let's take example to be able to buttress our point. Let's say example 1. Let's take example 1. Determine if AB is parallel, this is symbol for parallel, or perpendicular, this symbol for perpendicular, to PQ in each of the following. So the first one, we have A to be 3,1, then B is 4,3. So P to be 4,6, then Q to be 5,8. So this is the first one. Then the second one, we have A to be minus 1, minus 2, then B is equal to 2, minus 3. P is equal to 5,4, then Q is 6, 7. So this is what we are given. We want to determine if AB is parallel. This is symbol for parallelism, and this is symbol for perpendicularity. So we want to see if A is parallel or perpendicular to PQ. AB is a line. AB is a line. PQ is another line. So what do we do there? We have to A, the first one. We find the gradient. We say let M1 represent, let M1 be the gradient. Let that one represent the gradient of AB, line AB, and M2 to represent the gradient of line PQ. Okay, so we go ahead and find the gradient of line M1. M1 will be equal to Y2 minus Y1 all over X2 minus X1. That is the formula for to find the gradient of a line. So this first one will be X1, Y1, X2, Y2. So from here, we are going to have Y2 to be 3 minus 1 all over 4 minus 3. And that will be 2 all over 1. And that is equal to 2. So the gradient M1 is 2. Then the second gradient, Y2 minus Y1 all over X2 minus X1. So in this case now, for P, this is for PQ, I'm going to have 8 minus 6 all over 5 minus 4. And that will be 2 all over 2. And that is equal to 2. So in this case now, we realize that M1 is equal to M2. So what can we say about the two lines P and Q? The two lines AB and PQ? It simply means that since their gradients are equal, it simply means that line AB is parallel to line PQ. And that is what we are expected to get. So if their gradients are equal, the implication is that the two lines are parallel. So, and that's what we have shown. In this example now, the A part of the example, line AB is parallel to line PQ. So let's go ahead and let's go ahead and check for the second example. So still the same thing. Everything is still the same thing. So in this case now, we now go, we check for this one, X1, X2, X1, Y1, X2, Y2. So let's check for PQ, for AB. For the second example, we want to consider the second example now. Y2 is minus 3 minus 2 all over 2 minus 1. Then at the end of the day, I'm going to get minus 1 all over 3 as the answer, because minus and minus is plus. That's the first thing we get. Then we go ahead and check for 2. The second one, PQ. We want to find the gradient of PQ. So here, this is X1, Y1, X2, Y2. So we have 7 minus 4 all over 6 minus 5. Then I'm going to have 3 all over 1, and that is 3. So what can we say about the gradient, the two gradients here? If we multiply the two gradients, M1, M2, what are we going to get? M1 is minus 1 over 3 multiplied by 3 over 1. Then at the end of the day, we have minus 1. So what is the implication? It simply means that AB, line AB, is perpendicular to line PQ. Because under condition for perpendicularity, the product of the two gradients must be equal to minus 1 when the two lines are perpendicular. But when the two lines are parallel, they have the same gradient. Their gradients are equal. So this is how to find the angle between two lines. If you want to know the angle between two lines, it depends on the nature of the two lines. The two lines could be either parallel or perpendicular. If the two lines are perpendicular, the product of their gradients will be equal to minus 1. But if the two lines are parallel, they have the same gradients. I would love to stop here. Because of our time, we'll continue from there in our next class. Thank you, and God bless you.